Welcome. We're now going to approach problem 3 of discussion 6A of spring 2018. So question 3 talks about how we would talk about the computability of a problem with regards to the halting problem. Now, the question itself is just building on the fact that given that you have some program, let's call it A, and you have some hint or intuition as to the fact that A is uncomputable, right? And you want to prove this. Now, constructing complicated proofs like the kind we did for the halting problem might not always be feasible or even required. So instead, what we do is this idea that is often used in other places in CS theory and algorithms as well, of something called reduction. So we make this claim. We say, look, if A can be computed, or if A can be written or solved or whatever, then this implies that the halting problem can be solved, right? If you look at the contrapositive of this statement, the contrapositive says if the halting problem can't be solved, then A can't be computed, right? So if I can show this, that is equivalent to showing this. But then I already know that the HP can't be solved. And then it follows that if I have shown the outer box and I know the halting problem can't be solved, it must follow that A can't be computed. So that is how I would go around constructing a proof as to what is called the uncomputability of A. So a little less abstractly, what you really have to do is show that this implication is a valid implication. How would we go about doing that? The idea is we say, OK, let A be computable, right? So we have now entered the if part of that implication. So we say let A be computable. And now we have to use the fact that I already have A to, so use A to solve the halting problem, right? And this is what we did, for example, if you read up the lecture notes on solving what we had called the easy halt problem, where we said, look, does a program not halt in general on some input X, but halt on 0? And we had said, look, if we have a program which can do this, we can use easy halt. And using easy halt, we will solve the halting problem, right? And then we had shown the older implication. So now, looking at question 3, we say that we want to prove that a program A is uncomputable. And then we show that the halting problem could be solved if A could be solved. And it's this idea of contraposition and reduction that lets us do this very well.